Okay, good evening. This is Professor David J. De Los Rios. Okay, my discussion for tonight will be a long video format video, and this is still under college algebra. Okay, let's proceed. So, for those of you who are following my long video format lectures on college algebra, this will now be college algebra lesson number 16. I am now on lesson number 16. Okay. And the title of the topic for tonight will be System of Linear Equations in Three Variables. Three variables. It will now be three. Okay? Because lesson number 15 and 14 actually system of linear equations involving two variables. So for tonight, lesson number 16, it now involves three variables. It is one of the worst problem under college algebra. Okay, but I will assure you that as long as you know your fundamental operations, okay, you will not be hard up on this topic. Okay, let's try to bring out uh, system of linear equations involving three variables. An example of a linear equation that involves three variables will be an x plus 3y plus z is equal to 4. Okay? It is a linear equation because all the powers of x, y, and z are actually 1. We got an x, the power is 1. We got a y variable in the equation, and the power is also 1. And we got a z variable, and also the power is 1. So they are considered linear. Okay? Linear. And there are three of them, that is x, y, and z. The main problem here is to compute for the unknowns value x, y, and z. Because there are problems in real life in which if we try to formulate it, it will fall under a system of linear equations involving three variables. So if you have encountered a problem something like that, the solution and how to bring out the solution for that equation will be the one we will be discussing tonight. Okay, let's try to bring out the method of solution. For the method of solution, the simplest method of solution is actually the one I will be discussing tonight, and that is by using the so-called elimination method. There are advanced solutions for this, okay? But for the meantime, we will not be discussing those advanced solutions. That will be another topic maybe. But for tonight, I will be discussing the method of solution, which is the so-called elimination method. Okay, let's try to bring out a focus variable. If we try to define what is a focus variable, it is the first variable to be eliminated in the process. The solution is by focusing on the so-called focus variable. Focus variable is the first variable in which we will try to eliminate first from the given linear equations. Okay, it's hard to visualize what is a focus variable for the meantime, but if I will give you an example problem, okay, you will try to visualize what is a focus variable. Okay, I will give you an example problem so we could visualize what is a focus variable. Solve for x, y, and z. We are given three system of linear equations, three linear equations involving three variables. Equation number 1 is 2x minus 5y plus 3z is equal to negative 1. That will be equation number 1. The next system of linear equation that contains another 3 variables, okay? X plus 4y minus 2z equal to 9. That will be equation number 2. Okay? And the third system of linear equation is x minus 2y minus 4z equal to negative 5. And that will be equation number 3. Okay, so for those of you who are taking SET exams, okay, this might come out, but this is one of the worst case scenario problems that will come out under CET or SET maybe. So let's try to bring out the solution of this. Just in case it will come out, you could use the solution I will be presenting tonight. Anyway, the SET and CET exams are actually multiple choice, you know. If you could bring out, what you call this, as soon as possible, your solution for the equation, you could bring out, or you could bring out the proper choice for the solution. Okay, let's try to bring out the solution of these 3 system of linear equations. Solution. We will let x equal to the focus variable. Okay? Meaning to say, from the given 3 linear equations, we will try to eliminate first x. Okay? That's the main concentration. That's why it is so-called focus variable. The first variable to be eliminated. Okay? We will try to simplify the 3 system of linear equations. So what we will do is that we will eliminate x using equation number 1, equation number 2, and equation number 3. Okay? Let's try to bring out or how we eliminate x variable. Using equation number 1. Using this equation here. We will try to compute for x as a function of y and z. Okay? That's our main concentration. So this x here is referred to as the focus variable. Okay, so using equation number 1, x will be, you could visualize it, x will be equal to, we transpose this one and this one to the right, and we will divide all terms by 2, because there is a coefficient 2 here. So x is actually equal to 1/2 times the quantity 5y minus 3z minus 1. We call this equation 1a. Okay? We are now given the relation of x in terms of y and z by manipulating equation number 1. Okay, since we manipulated equation number 1, we will change its name. We put it as equation number 1a. Okay? Using equation number 2. If we try to compute for x in terms of y and z, x will be equal to minus 4y plus 2z plus 9. We will transpose this 4y and minus 2z to the right, so that will be x. So x is actually minus 4y plus 2z plus 9. So again, we are given another x, same value of x, as a function of y and z from equation number 2. Okay, and we call this equation 2a. So the one we are eliminating actually is actually x. That's why I put it here. We will put x to be equal to the focus variable, the variable or the unknown to be eliminated first. Using equation number 3. Again, we will compute for x. X will be equal to, we transpose this minus 2y and minus 4z, so it will become 2y plus 4z minus 5. That is the value of the focus variable x using equation number 3. And we call it, since we change the form, it's not, we just rearrange it, we call it equation number 3. Okay? So again, we are given x as a function of y and z. So from the previous manipulation, we got 3 equations, 1a, 2a, and 3a, involving x's, right? Okay, so to eliminate x, okay, we will equation 1a into a. We will take equation 1a into a. Because this is x and this is x, we will equate it. Okay, if we try to equate it, the value of x using equation 1 is 1 half times quantity 5y minus 3c minus 1 close quantity equal to the value of x using equation 2a. Okay, is minus 4y plus 2z plus 9. If you try to visualize this one, okay, there are no more x. That's why we eliminated x by equating equation 1a into a. So what will come out now will just be simply a function of y and z, and they should be equal to 0. It contains only two variables now. And to solve a linear equation involving two variables, that will be lesson number 14. Okay, the past lesson. So meaning to say, we are simplifying the solution of this so that it will go to the system of linear equations involving only two variables. Okay, so if we try to simplify this one, okay, this is pure algebra. The equation involving y and z as the first equation will be this one. Okay, no more x. We eliminated x already after the equating, right? So what comes out is 13y minus 7z minus 19 equal to 0. This is just a algebra portion, okay? We call it equation number 4. So this is now a pure function of y and z, and this should be equal to 0. No more x. We eliminated x by equating 1a into a, okay? And to get another relation involving y and z, okay, we will equate equation 2a and 3a. So the next step is equate 2a and 3a. 2a is actually minus 4y plus 2c plus 9, it is this. And 3a is actually 2y plus 4z minus 5. If we try to simplify this one, this is just pure algebra. What will come out will be this one. Okay? After the equating of equation 2a and 3a, we eliminated again x, the focus variable. That's the focus variable. X is the focus variable. We want to have it eliminated. So actually, we are given a next equation involving a function of y and z, and they should be equal to 0. Two variables. So to solve an equation, linear equation involving two variables, okay, you can now use the so-called elimination by addition or subtraction, or the solution by substitution. But what I will be presenting tonight will be elimination by subtraction. Okay? So I will try to multiply equation number 5 by number 7, by 7. I will try to multiply equation number 5 by 7. So minus 3y times 7 will be minus 21y. Minus z times 7 will be negative 7z. And 7 times 3 will be, 7 times 7 will be 49 equal to 0. We call it 5a. I try to multiply the equation 5 by 7 because if I will subtract equation 5a from 4, okay, it will become, I will rewrite equation number 4. Equation number 4 is 13y minus 7z minus 19 equal to 0. So if I will try to perform the operation subtraction, this here cancels. This one. They will cancel. So actually, if we try to perform the operation subtraction, after the multiplication of equation 5 by number 7, okay, what will come out will be minus 21y minus 13y, and minus 7z minus 7z, this will become plus z, 7z, minus 7z plus 7z, it will be 0. We eliminated c already. So our solution for this portion here is elimination by subtraction. And they should be equal to 49 minus 19. So that will be plus 19 equal to 0. Okay? So after the subtraction, The only variable now remaining is actually y. So actually we could now compute for y. That was lesson number 15 or 14. Okay? So minus 34y plus 68 equal to 0. Minus 34y equal to negative 68. Transposition. Y will be negative 68 over negative 34. And negative over negative will be positive. 68 over 34 will be 2. So the unknown value of y is actually 2. Okay? So you could observe the solution. We try to compute for x using equation number 1, 2, and 3. We equate 2a, 1a and 2a. We equate 2a and 3a. Okay, then we will try to eliminate one of the variables by using the operation subtraction. So what comes out for the value of y is actually equal to 2. Okay, so to compute for z, you could go back to either equation number 4 or number 5. But I prefer equation number 4. Equation number 4 is 13y minus 7z minus 19, it is this, equal to 0. Okay, so from this equation, it only involves y and z, right? Y and z. We now know y. So to compute for z, I just put the value of y equal to 2 here. So this is 13 times 2 minus 7 times z minus 19 equal to 0. If we try to simplify this, what comes out for the value of z will be positive 1. Okay? Because equation number 4 only involves y and z, and we now know y. So to compute for z, use equation number 4. We could also use equation number 5 if you would like. It's the same. So to compute for the third variable, because we now know y, right? We now know z, right? So the only remaining unknown now is x, the focus variable. So we could either go back to equation number 1, number 2, or number 3, and we could compute for the value of x. I prefer using equation 1a. 1a. 1a or 1, they are the same because we just rearrange the terms. For equation 1a, where is equation 1a? This is. Equation 1a is actually 1/2 times the quantity 5y minus 3z minus 1. We now know the value of y. We now know the value of z. Y is equal to 2 and z is equal to 1. Substituting values, and if we try to simplify, the value of x is actually equal to 3. So the final answer to the solution for tonight will be x is equal to 3, y is equal to 2, and z is equal to 1. And to check the validity of answer, we could substitute the value of x, y, and z to any of these three equations here. I prefer equation number 2. Equation number 2 is 2x minus 5y plus 3z equal to negative 1. If we try to substitute the value 3 to 1 for x, y, and z, after the substitution, what comes out is negative 1 equal to negative 1. It is true. Okay? So the total solution for this three system of linear equations involving three variables, x is equal to 3, and y is equal to 2, and z is equal to 1. That's it, guys. That's the simplest solution of a system of linear equations involving three variables. You try to bring out your focus variable, okay? You try to bring out two system of linear equations eliminating the focus variable. So if you are now given a system of linear equations involving two variables, you can use substitution or elimination by addition or subtraction to solve for the unknown. Then you could either go back to one of the linear equations in the original to compute for the third one. Okay, that's it, guys. So for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. Okay, try to watch my long form video format. You will gain something from it. Okay, good evening from Los Angeles.